Grenade Type 1, the Fragmentation Grenade. The Fragmentation Grenade is the most widely recognized grenade type and the one most commonly associated with military combat. The most common type used in wartime is the Explosive Grenade, which contains TNT encased in an iron jacket. When the fuse detonates the explosive, the iron jacket breaks into fast-moving lethal fragments. These fragments, sometimes called shrapnel, are what make fragmentation grenades effective against personnel rather than against structures or vehicles. The iron casing of a modern fragmentation grenade is specifically engineered to shatter into predictable fragment sizes upon detonation, maximizing the number of lethal projectiles produced per grenade. The standard U.S. military fragmentation grenade is the M67, introduced in 1968 and still in service today. It is spherical, approximately 2.5 inches in diameter, and weighs about 14 ounces with the fuse. The M67 contains 6.5 ounces of Composition B explosive. Upon detonation, it produces fragments with a casualty radius of approximately 15 meters and a danger radius of 230 meters, meaning fragments can travel far enough to injure the thrower if cover is not taken immediately after throwing. The average soldier can throw the M67 fragmentation hand grenade 40 meters. The math between throwing distance and casualty radius makes cover non-optional. The classic World War II American fragmentation grenade was the Mark II, nicknamed the Pineapple for its grooved exterior. The Mark II had a grooved exterior originally intended to aid fragmentation of the grenade. However, later studies showed that this design has no effect on fragmentation, though it does provide a non-slip surface that improves grip. The grooves were decorative engineering, a solution to a problem that did not exist, retained because the grip benefit proved genuinely useful. Grenade Type 2. The Stun Grenade, Flashbang. The stun grenade, commonly called a flashbang, is designed to temporarily incapacitate rather than kill. Upon detonation, the M84 generates an intensive heat, a flash of over 1 million candlepower, and a bang that is 170 to 180 decibels at 5 feet. The grenade can cause disorientation, confusion, ear injuries, and temporary loss of hearing within 9 meters. The flash may damage eyesight and night vision. The M84 is the standard U.S. military stun grenade and is recognizable by its 2 hexagonal end caps on a perforated tube. Stun hand grenades are used as diversionary or distraction devices during building and room clearing operations when the presence of non-combatants is likely or expected, and the assaulting element is attempting to achieve surprise. The stun grenade's primary tactical application is in hostage rescue and close-quarters combat situations where the goal is temporary incapacitation rather than lethal force. Clearing a room before an assault team enters, or creating a window of disorientation in which armed personnel can be neutralized. The stun grenade has also crossed over into law enforcement use in riot control and high-risk warrant service situations. Its limitations are significant. Stun grenades do not reliably incapacitate everyone in a room, and they can cause serious injuries, including permanent hearing loss, eye damage, and burns at close range. Their effectiveness depends heavily on the geometry of the space they are deployed in and the position of the targets relative to the detonation point. Grenade Type 3, the Smoke Grenade. Smoke grenades are burning-type devices. They do not explode in the conventional sense, but rather ignite a chemical filler that produces a dense cloud of colored or white smoke. The ANM-8HC grenade produces dense clouds of white smoke for signaling and screening. The M18 colored smoke grenade is available in red, yellow, green, and violet variants. The color code communicates specific tactical information, marking positions for aircraft, signaling friendly forces, or identifying landing zones. The tactical applications of smoke grenades are entirely non-lethal. Smoke is used to provide visual cover during movement, to obscure the position of friendly troops from enemy observation, to mark targets for close air support, or to signal for extraction. A smoke grenade creates a temporary area of reduced visibility that can allow forces to move, withdraw, or breach a position without being observed from a distance. White phosphorus smoke grenades, designated Willie Pete by American troops, carry an additional capability beyond pure screening. The M15 is a white phosphorus smoke grenade, used for screening and signaling purposes. WP has many of the same properties as HC and is also burned to create the effect, giving the M15 a similar incendiary capability. White phosphorus continues burning on contact with air and is extremely difficult to extinguish, which gives white phosphorus smoke grenades a secondary incendiary function that standard HC smoke grenades do not have. Grenade Type 4, the Incendiary Grenade. The Incendiary Grenade is designed not to kill personnel but to destroy equipment, start fires, and render vehicles and weapon systems inoperable. The AN-M14TH3 incendiary hand grenade is used to destroy equipment or start fires. It can also damage, immobilize, or destroy vehicles, weapon systems, shelters, or munitions. The filler in modern incendiary grenades is thermate. An improved version of thermite, the incendiary compound used in grenades since World War II. A portion of thermate mixture is converted to molten iron, which burns at 4,000 degrees Fahrenheit. The mixture fuses together the metallic parts of any object that it contacts. The thermate filler can burn through a half-inch homogeneous steel plate. It produces its own oxygen and burns underwater. The ability to burn underwater and burn through steel plate makes the incendiary grenade effective in situations where conventional explosive grenades would be useless. Destroying artillery pieces, engine blocks, communications equipment, and weapons that cannot be transported or that must not be captured by enemy forces. The incendiary grenade is a denial and destruction tool rather than an anti-personnel weapon. The M14 is primarily employed on material to be destroyed in a roughly secure environment and not as an offensive or defensive weapon. The grenade has the ability to melt right through an engine block. Grenade Type 5, the Concussion Grenade. The Concussion Grenade, also called the Offensive Grenade, is designed to produce a lethal shock wave rather than lethal fragments. Offensive grenades had no heavy metal case to produce fragments and relied purely on the blast of the high explosive for their effect. This meant they had a much smaller lethal radius, and the thrower did not have to take cover after throwing the grenade. The tactical distinction between fragmentation and concussion grenades maps directly onto the distinction between defensive and offensive use cases. A fragmentation grenade requires the thrower to take cover because the lethal fragment radius exceeds typical throwing distance. A concussion grenade does not require the same cover because the blast radius is smaller and predictable. This makes concussion grenades more suitable for offensive operations where the assaulting force is moving forward and cannot pause to take cover after each grenade throw. Concussion grenades were widely used in World War I trench warfare, where the goal was often to stun or kill enemy soldiers in enclosed spaces rather than to produce fragmenting shrapnel that could endanger friendly troops on the other side of a thin partition. The modern flashbang is a descendant of the concussion grenade concept, a non-lethal evolution of the same fundamental design philosophy of using blast and shockwave rather than fragmentation as the primary mechanism of effect. Grenade Type 6, the Rifle Grenade. The rifle grenade is a grenade designed to be launched from the muzzle of a standard infantry rifle rather than thrown by hand, extending the grenade's effective range dramatically beyond what an arm can achieve. There are also rifle grenades and rocket-propelled anti-tank grenades. A standard soldier can throw a hand grenade approximately 40 meters. A rifle grenade extends that range to 150 to 300 meters, depending on the specific round and launching system. The mechanical principle of a rifle grenade involves a cup launcher or spigot launcher attached to the muzzle of a rifle, into which the grenade is inserted. A blank cartridge fires to generate gas pressure that propels the grenade forward without a live bullet. The modern evolution of the rifle grenade concept is the underbarrel grenade launcher, the M203, and its successors attach beneath the barrel of an M4 or M16 rifle and fire 40mm grenade rounds. This system has become standard in U.S. infantry units, with one soldier per fire team typically equipped with the launcher capability. The 40mm grenade launcher round can be loaded with fragmentation, smoke, illumination, or less lethal rounds, making it a versatile platform that extends the unit's ability to deliver different grenade effects at range without requiring dedicated crew-served weapons. In October 2025, FN America received a development contract for a compact precision grenadier system prototype incorporating smart munitions for improved accuracy and reduced weight, the next generation of the same underlying concept. Grenade Type 7, the Antitank Grenade. The Antitank Grenade represents one of the most specialized applications in grenade development. An attempt to give infantry soldiers a hand-deliverable weapon capable of penetrating tank armor at close range. There are also rifle grenades and rocket-propelled anti-tank grenades. The anti-tank grenade concept peaked in World War II, when infantry units frequently faced tank threats without access to heavy anti-armor weapons and needed a close-range solution that could be carried by a single soldier. The most effective anti-tank grenades used shaped charge technology, concentrating explosive force into a narrow jet of molten metal that could penetrate armor. The British No. 68 anti-tank rifle grenade used a shaped charge and was capable of penetrating approximately 52 millimeters of armor. The German Panzerfaust, technically not a hand grenade but representing the same concept extended to a disposable rocket launcher, could penetrate up to 200 millimeters of armor and became one of the most feared infantry anti-armor weapons of the war. The anti-tank hand grenade as a primary weapon system was essentially rendered obsolete by the development of dedicated rocket launchers and guided anti-tank missiles. Modern infantry anti-armor weapons provide greater range, greater penetration, and greater accuracy than any hand-thrown device could achieve. The anti-tank grenade survives in some military inventories as a secondary tool, but its role in the anti-armor mission has been entirely superseded by more capable systems. Grenade Type 8, the Tear Gas Grenade. The Tear Gas Grenade, formerly designated a riot control agent grenade, deploys chemical irritants that cause temporary incapacitation through respiratory and eye irritation without causing permanent injury to healthy adults at typical deployment concentrations. The standard U.S. military tear gas grenade deploys CS gas, 2-chlorobenzalmalononitrile, a chemical irritant that causes involuntary tearing, burning, sensation in the eyes and throat, and respiratory discomfort. CS gas was developed in the late 1920s and has been standard in riot control and certain military applications since the 1950s. The current U.S. policy governing the use of CS and other riot control munitions is found in Executive Order 11,850, issued on April 8, 1975. CS irritant gas may be employed in a combat zone with the approval of higher authority. U.S. forces will employ CS in wartime defensively only to save lives as approved by the President. The restriction on combat use of tear gas reflects the broader framework of the Chemical Weapons Convention, which prohibits the use of chemical agents as a method of warfare while permitting them for law enforcement and riot control purposes. The tear gas grenade's primary application in the 21st century is law enforcement rather than military. Riot control deployments and high-risk warrant service are the dominant use cases. The grenade delivers its chemical payload through a burning fuse system rather than an explosive detonation, producing a sustained cloud of irritant for the duration of the burn rather than a single instantaneous release. The effects are temporary and largely reversible in healthy individuals. The design goal is incapacitation without injury,